we're changing rational form back to root form, we're basically reversing the steps. So on the outside of the radical, the denominator of our fraction goes on the outside of the radical. And then under the radical will be x to the numerator, so in this case x squared. This is read the cubic root of x squared. If the denominator would have been 4, it's the 4th root of whatever. If it would have been 7, like in the next problem, we call that 7th root. We don't have a 1 root, so the smallest number you'll see when writing something in radical form will be 2. So go ahead and complete the next 2 problems. Turn the video back on when you're ready to check your answers. So for the next 2 problems, the denominator is 7, so it's the 7th root of y to the 4th. And then the last problem is the square root of z to the 5th. Now because this is the only case where this is true, because it's a 2, we can leave the 2 off and still call it the square root of z to the 5th, but the 2 is implied when you have a radical number there. Now for the next 2 problems, the way they are written, we have to actually write a radical for the 8 and then a different radical for the y. And the reason is because both denominators are not the same. So the way we fix that problem is we look for that least common denominator between the 2 numbers, and we write both the 8 and the y with the same denominator. So if you go ahead and think about it, turn the video back on when you're ready to continue, when you have that common denominator. So the first common multiple, so we're listing numbers, like 3 times 1 is 3, 3 times 2 is 6, 9, 12 is next. I did the same thing with 6, which would be 6 times 1 is 6, 6 times 2 is 12. The first number they share is 6. So that would be the denominator that we could write both of these into. The y is already done, it's already in 6. To change the 8 into with a fractional exponent with a 6 as a denominator, we would multiply both numerator and denominator by 2, which would give us 8 to the 4 6. So now we have a radical. Now we can write this as a single radical, and it will be a 6th root because both denominators have a 6. So the 8 would be 8 to the 4th power, because our new numerator is 4, and the y would be to the 1st power. So this would be the 6th root of 8 to the 4th times y to the 1st. The last problem, we have 3 different denominators, so go ahead again, figure out what that common denominator is, and then see if you can take one step further and actually write the final answer. When you're ready, go ahead and turn the video back on. So hopefully, like the previous problem, you chose 6 as the common denominator with 3 bases. So the y exponent will not change. The x exponent, we will multiply both numerators and denominators by 2. And for the 3 exponent, we would multiply both of those by 3 to get everything in 6. And because of that now, instead of writing 3 separate radicals, one with a 2, one with a 3, one with a 6, we can now write it as a single radical of the 6th root of, and it's going to be 3 to the 3rd, because the numerator here is 3, x to the 2nd, same reason, the numerator is 2, and the last one is y to the 5th, so our numerator is 5. So for our last 2 problems, we're going to basically take the 2 ideas we talked about and in this video and kind of combine them. To be able to solve equations where we have something in root form, the first step is to turn it back into the base to a fractional exponent. Once we do that fractional exponent, then we can go back to what we were doing back here, where we are actually solving the equation by getting the exponent from whatever number it is into x to the 1st power. So think about the 2 things we worked on today, and we're going to be using both of those here. So first step is turn it back into basically x to some exponent or the second one, y to some fractional exponent. And then the second step is to solve the problem by getting the exponent to be a 1. In the second problem, we'll get that exponent to be a y to the first power. So go ahead and take a look at the first one. Once you do both first steps in both of them, and then turn the video back on when you're ready. So the first one here is going to be x to the 2/3. Again, this is the numerator. This is the denominator. So it's going to be x to the 2/3 equals 40. And for the second one, it's going to be y to the 5/6 equals 156. Second step is we want to change that exponent from 2/3, 5/6 to a 1. So go ahead and think about what we did today or what we did last week. When you're finished with both problems, turn the video back on. So to get an exponent of 1, we're going to multiply the 2/3 by 3/2. That's going to give me x to the 6/6 on the left side, which is 1. And it's going to be 40 to the 3/2. So x will be approximately 252.982. The second problem, we're going to use 6/5 as the exponent because I multiply 5/6 and 6/5. I'm going to get 30 over 30. 30 over 30 is 1. This means y is equal to 156 to the 6/5 exponent. So it's going to give me a final answer of 428.301. If you have any questions on this activity, please reach out to your teacher.